we're talking about prototyping workflows using Snap. Workflows automation has become a very popular kind of programs. We have applications such as Make, and Zapier, or Microsoft Power Automate, or even Sub-Build process automation. They use graphical low code in order to make these to implement these automations. Technically, they are based on flowcharts, and the aspect. The next slide, please. And the aspect is what we can see here. For instance, this is the Make application. They let the user to build flowcharts. They have an accurate design, a nice design, something that feel comfortable. Okay. So this is basically a flowchart. The next one, we can see another applications. For instance, N has another design, but basically it's the same. Nodes and arcs and graphically a flowchart. In the next slide, we can see Zapier. Zapier puts, instead of horizontally, it puts vertically. And we can see here basically blocks that are actions. Then there are also decisions, a kind of different paths or branches. And also, if we go in the next slide, we can see even loops on iterations. In the last block, we can see a for each, for instance. Okay, in the next slide, what we can see, well, here is this Build Process Automation. It has a tool, it's very similar, the aspect with Zapier and Microsoft. Okay, in the next slide, we can see the algorithm foundations that can be stated by Edgar Dijkstra in 1970. And he, in this paper, explained the basis of structured programming. In the next slide, we can see a synthesis of this discourse that we can, flowcharts can be structured, and there are three basic blocks, building blocks, with expressed in flowchart graphically, that correspond to the basic algorithmic structures. Now we have a sequential, we have decisions, if else, and we have loops. And here there is a correspondence in Snap. In the next slide, this is a relation of the basic elements of these automation tools. We have, they use different words, different vocabulary. Some of them, they use the word action, task, or even event or trigger. They use decisions and loops, and also they introduce the term connector. Let us talk about connectors. Here is a presentation how Make, for instance, present the list of connectors. They use also a nice graphical presentation. And here we can see connectors for different tools. We have connectors for Gmail, connectors for WhatsApp, Telegram, also connectors for enterprise applications, SAP, Microsoft Dynamics, or tools like WordPress, or even databases. There are many connectors. In the next slide, we can see the landscape of connectors that Make present. And there are more and more connectors. Talk about to almost 3,000 and growing. No, and here is the case of Make. But in the next slide, we can see the proposal of N at N is very similar, thousands of connectors. And in the next slide, we can see the proposal from Zapier, thousands of connectors. And in the next slide, we can see the proposal from Microsoft, again the same. So there are a lot of connectors for each platform. How can we understand the notion of connector in Snap? This proposal, connector can be simply a category. So in this case, there is a basic example of a connector to Google Gemini. Here we can see very simple blocks. The possibility is prompt. So in the prompt, you enter text, and then when you click, and we get the answer of the Gemini. No? But in this case, there is a simple example because we asked for the 10 first we get a list, and then we can ask for, okay, give me the list in JSON format. And then what we can do is get in the format that we can convert to snap list, for instance. No, what which is interesting is how can we implement these connectors? Well, this connector here, the connector is in fact is a category with a set of blocks, but it's the same idea with the platform we have seen. When you drag and drop the connector, appears blocks and appears triggers with functionalities to connect to the system of the connector. So in the next slide, we can see that we have two approaches to implement these blocks, these categories. We can do it in a pure snap implementation, or we can use an external bridge, do this with an external bridge agent support. With pure snap, the advantage is there are no dependencies, but it is very limited architecturally and technically. But using external bridge with an independent agent, we have these limitations. We can do a lot of things with the APIs, and architecturally is almost without limits. In the next slide, we can see the elements when you implement with a pure snap is limited because we can call APIs that use, for instance, API, but API, this is a drawback because the API is visible in the code, and many APIs cannot be called directly from browsers for security reasons. But in the next slide, we can see the approach using external bridge. External bridge means that we have a piece of software. In this case, the approach is using in Python. There are many one, but there is a Flask. There is a library that can let you start a server, a small server using Python, and then from Python you can make calls to any API. We have seen that there are thousands. That means thousands of connectors. That means that there are thousands of systems that they have APIs that can be called using different mechanisms. No? And the advantage is we can access to the connector from Snap using HTTP and MQTT, and the reverse. We can connect to Snap using MQTT. In the next slide, we can see an example of a small example of a bridge. This is the code of the bridge that connects to the Gemini system. So basically, there is a web service and a REST service that you send the prompt and you get the response. And here we can see we are using the libraries to connect to this API. In the next slide, we can see the internal implementation of this block prompt using the independent. Here we are calling the API directly. Here is the code, and this slide is missing a link in the version that I will put into the platform. And here will be the link to go to this example that anyone can get and use it. The only thing you have to do is to substitute the key API, the API key, and then it will work. And the other version is when using an external agent. Basically, the only thing we do is to call an URL, and calling this URL, you get the response. Okay, in the next slide, well, this is a basic example. We have made some experiences using this idea of connectors with real companies, and we make an experiment in SIL. SIL is a logistic conference in Barcelona, and there were a booth from an incubator. So incubator is very pleasant work with startups at an incubator. They are very, very proactive, so very motivated. And we propose two companies to make an experiment, make a workflows using Snap. Okay. The first example is Pulpop. Pulpop is a marketplace. It's a marketplace for small and medium enterprises. It's like an early Amazon for having an idea, but they have an API, and we implement the connector. Now the experiment is they have to use the connector. In the next slide, we can see the example. In this case, they wanted to try a workflow to create a new product very easily. And very easily meant, okay, using a very known interface, WhatsApp. But we didn't use WhatsApp because we have to pay the license, the enterprise license, but with Telegram, we can do the same free. Okay, in Telegram, the idea is take a shot, take a photograph, and in the title, put the name of the product, @ and the price, and then send to the platform and then insert directly into the platform. What we did is to develop these blocks that you can see. And also here we can see the notion of trigger implemented in Snap. Trigger basically is an event. So we can have, you can have actions, we can have workflows, we can have decisions, we can have loops, and we can have events. And okay, once here, which is interesting, is the interaction user is done via Telegram, and then the events are received by Snap. Snap is that is where is implemented the logic. In the next slide, we see the consequence of this action, and then we get into the platform and you see that the photograph has been updated with the title and the correct price. The last example was more sophisticated, is a platform for small farmers, farmers that want to connect to their customers, connect small shops and with other farmers. In this case, it's directly with the customer. Here, the example was most complicated. We can see in the next slide. Here is a flow. The flow here is in the upper block. If you make click, what we do is simulate the receiving of an order from a customer. Then the farmer receives a message. In this message, we can see an attached PDF file and then a question, accept, confirm, yes or not. Then if we click on the PDF in the next slide, the user can watch the content, the detail of the content of the order. So, Jordi, if you go to the next slide, yes, when the user click on the PDF, this PDF come across the connector via API. In the next slide, also there was another functionality. I want to consult the orders, the pedidos that are pending, so I can write / the order, and then I get the list of all the pending, and then I can make the same consult and accept or reject. And here the number of blocks were more sophisticated, but it's an example of the experience. Finally, conclusions, recap, the last slide. The idea is that block-based languages like Snap are a lingua franca for almost a whole new generation. There is being used in schools. There are in the curricula in almost all schools in the OECD. But probably in the next 10, 20 years, we have see the consequences. This is a generalized literacy on those concepts. So there is no need to create parallel discourses to explain computational thinking. This is what that company does, that companies do. Make Zapier, they explain a tale, explaining what is computational thinking without entering the details of computational thinking. And so they begin from scratch and they're trying to explain that is very simple, but in fact, there are sometimes not so simple because it's better to explain directly, clearer the concept. So the computational thinking, algorithmic thinking, decomposition, abstraction, and pattern recognition. The other conclusion is that undergraduate programists can develop connectors. It is, and even with the help of artificial intelligence, is easy in most cases. And finally, the last conclusion is that Snap is architecturally complete because it's bidirectional, synchronous with synchronous and asynchronous connections to the connectors, and it is thanks to Web Service Access library and the MQTT included library in Snap. Thank you very much.